All right, we want to take a look at a triangle, and it's not a right triangle. It's just any triangle. And the way we're labeling it, we're using sort of this corner, which we would say, oh, that's A. We're just sort of putting the A in there to represent the angle. Capital C to represent the angle here, capital B here. Notice we made the sides across from the capital B be a B. Across from the capital A, we use a lowercase a, and across from the C, we use a C. Right? Just a way of notating some things. And then we could also have used Greek letters, theta and alpha and so forth. But for simplicity, we wanted to sort of keep it a relationship between capital A and the side across from it, A. So let's say here's our picture. Well, there's a relationship that exists here. And it's called the law of cosines. And it helps us find a missing side or a missing angle if we're given enough information on any triangle. Okay, on a right triangle, we already know how to take care of things. But what if it's not a right triangle? Well, this takes care of things. So here's what it says. It says that this side right here, right, he is equal to this side squared plus this side squared. Now notice that very beginning part is just like the Pythagorean theorem. A squared plus B squared equals C squared. But since it's not a right triangle, what we're doing is we're coming in and taking out a little bit. We're taking out a little bit to get the right answer. So anyway, C squared is equal to A squared plus B squared minus 2 times the A length times the B side length times the cosine of that angle right here. That's the formula, okay? It is not difficult to use. We're going to look and see. So here's what we have. Let's say we want to find that missing side. Well, this missing side is across from the angle. That missing side is, in our case, is always going to be C, okay? And it's across from the angle that is given. That's going to be our C side. So C squared is equal to the one leg squared plus the other leg squared minus 2 times each one of them times the cosine of the angle between them, which in this case is going to be 48 degrees. Well, let's fill in the A and B. So C squared, we don't know. A, 12 or 15 can be the A. It doesn't matter. We'll make the 12. It's not going to change anything. B will be the 15 minus 2 times the one side times the other side times the cosine of 48 degrees. Now, let's come, I wrote that down because we're going to need to go to a calculator. So let's come back over to Google, and I have a calculator here, and we want to enter in because we can enter that whole thing in because it's just one big equation because the cosine of 48 is just a number. So I'm going to go, hey, 12 squared, which I know is 144. Now, one mistake, and I already made it. You better make sure you turn the calculator to degree mode. Okay, so 12 squared, which 144, plus 15 squared, which I know is 225, minus 2 times the 12 length times the other leg 15 times the cosine of 48 degrees. And it says, hey, that's 128.112. So if we come back here, we know C squared is approximately 128.11. But do we really want to know C squared? No, we want C. So what are we going to have to do here? We're going to have to take the square root of this side and square root of that side. So we'll have to come back to our calculator and take the square root of that. Square root of that, I think it'll do the answer there. No, square root of that 128.11, so forth, is 11.3, let's say. So we can come back here and say, hey, that means C is approximately 11.3. That's all I have to do. And the nice thing here is when we're finding that missing side across from the angle, this can all be popped into a calculator and get your answer very quickly. Okay, it's pretty simple. You just put it in. You just plug it in the numbers. And for our case, you're always, the side you're going to be trying to find, it's always going to be across from the angle. It's always going to be the C side if we're trying to find that missing angle when we're doing the law of cosines. We'll learn law of sines later. All right, let's look at this one. Okay, we have a missing angle. They gave us all the sides, but they're like, hey, find the missing angle. Well, what do? Well, I'm going to go c squared, a squared plus b squared. Okay, I have it in memory because it's just like Pythagorean theorem. Then I have to subtract 2 times each one of the sides times the cosine of the angle, which in this case we don't know. We're given every single number in this equation except for the angle there. So who is c? C is always across from the angle. So 14 is our c. So 14 squared is 12 squared plus 15 squared minus 2 times 12 times 15. Again, a and b don't matter. They're interchangeable. 15 and 12 are. Times the cosine of theta. Now, we got to be careful here. Okay, 14 squared, that's 196. 12 squared, I know is 144. 15 squared, 225. Minus 2 times 12 times 15, that's 360 times cosine of theta. Now, a lot of times we try to combine that and this. But wait, this 360 is being multiplied by the cosine of theta. You can't. That's like 360x. And you would never combine 360x with these numbers. So what we want to do is combine the 144 and the 225. Yes, 369 minus 360 times this unknown. Biggest mistake is y'all try to put that 369 minus 360 and say it's 9 times cosine of theta. No, it's not. And if you do that, you're going to see that, yeah, you're not going to get an answer. It's going to mess up. So what I need to do now is notice I have a number here, 196, a number here, and then a variable piece here. So move the 369 over. So we're going to subtract 369 from both sides. Negative 173, I think so. Negative 360 cosine of theta. Now I've got to get cosine of theta by itself. You can see this is trickier, but not that difficult. Divide both sides by negative 360. That goes away. Negative divided by negative is positive. It doesn't matter. You can leave it, or you can leave the negatives, is equal to cosine of theta. Now we're got to figure out theta. How do I get rid of cosine? I take, as we learned last section, the inverse cosine. So the inverse cosine of 173 over 360. 173 over 360. So I need it's in degrees, inverse cosine of, that natural log there. Inverse. Okay. The inverse, I hit that button and notice it brings up cosine negative 1. There's my thing, R cosine. And it was what, 173 over 360. And it'll tell me my answer, 61.3 degrees, we'll say. So theta is approximately 61.3 degrees. That's the opening there, if those were real numbers. Takes a little bit of work, but all you got to do is just follow plugging in. Finding an angle is a lot more work than finding a missing side. The biggest thing is do not put those together. That's the biggest mistake I've seen over all my years of teaching this. Hope it all makes sense. Law of cosines.